All right, so time for our next unit, exponent rules. This leads to some really fun and exciting algebra stuff we can do later on, but we've got a lot of rules to learn. Now, we're going to talk about the rules themselves. We'll talk about the whys and where the rules come from. I'm going to recommend that you understand both, that you learn both. Not just that you memorize the rules, but that you understand and work to understand where they come from. That way, if you happen to forget the rule, you can kind of work it the long way if you have to. First chunk we're going to talk about is zero and negative exponents. Okay, this one's a biggie. It's a basis for a lot of things. Zero as an exponent. For every non-zero a, right? So I don't care what the number is. As long as it's not zero, a to the 0 power is 1. So, for instance, if I have 6 to the 0 power, that's not a very good pen. There we go. If I have 6 to the 0 power, that's the number 1. If I have negative 3, notice I'm going to put parentheses around it so I take the whole thing with me. To the 0 power, that's the number 1. Likewise, if I give you a fraction, 1/4, the whole thing to the 0 power is the number 1. It's a rule. Now, if you're curious to know why, by the way, I do have a video for you to check out on Khan Academy where it explains limits and that kind of thing and to where it all comes from. So. All right. Something else that is paramount to our understanding and ability to use exponents is negative exponents. For a non-zero number, a and any integer n. Okay. So notice here, by the way, that's kind of important that I say that the exponent itself is an integer. We'll talk about fraction exponents later on, but so anyway, if I have a, again, any non-zero number, to the negative n power, it technically forces it into the basement, is what I always like to say, but to the bottom of the fraction. For instance, if I have 6 to the negative 1 power, that's 1/6. If I have 4 to the negative 2 power, that's 1/4 squared, which, by the way, is 1/16, right? 4 times 4 is 16. So, again, it forces it into the basement, is what I like to say. Okay, so just kind of review the piece from your book. It's a zero as an exponent, again, for every non-zero number. A to the 0 is 1. So, again, here's our examples. Wonder where I got that negative 3 from. Negative exponent for every non-zero number a, and integer n. A to the negative n is 1/a to the n. For instance, 7 to the negative 3 is 1/7 cubed. Negative 5 to the negative 2 is 1/negative 5 squared. Now again, we can't use 0 as a base exponents. The first property on the previous page implies, again, 0 to the 0 would be 1, right? However, the problem is that we can't have both 1, so it's not possible for 0 to equal 1 and 0 at the same time, because we know that 0 to the 0 power is technically also 0. So in that case, we do call that part undefined. So we can't equal two things. And we run into those sort of things in math when we talk about like division by 0, right? We call that undefined for the very same reason, because there's two really good answers. So 0 to the 0 power is undefined, but anything else to the 0 power is 1.